high intensive computing with respect to data. So instead of going for our own infrastructure, procuring our own infrastructure and establishing our own infrastructure, we can go for a cloud provision, so that this can be elaborated, extended any point of time with a pay-per-use basis, and our jobs can be completed very fast. And in biological problems, we have seen protein structure predictions and ECG analysis. We feel that these are very high uh, computing intensive problems and data intensive problems. Biology, gene expression, data analysis for cancer diagnosis and things like that. Okay. Next, we will move on for geoscience, satellite image processing, which we know already, the MCF which we have here in Hassan. How MCF is doing all such jobs, doing lot of analysis on satellite image processing, how these are being handled by them and all can be seen. Geographical information system is wonderful problem for cloud computing. So all these problems can be sent, because when you look at, if it is non-textual data, the data will be heavy. It will be large data image will be there. The large size images need to be moved from one ground station to another ground station, or one ground station to a local storage, or any other location. As you know already, our master control facility available at different locations of our country, and that can be used. So let me go for that.
Okay, so let us start session 7. Okay, I was mentioning that gene provision, gene analysis, gene expression analysis for cancer diagnosis. Cancer is a disease characterized by uncontrolled cell growth and proliferation. This behavior occurs because genes regulating the cell growth mutate. This means that all the cancerous cells contain mutated genes. In this context, gene expression profiling is utilized to provide a more accurate classification of tumors. The classification of gene expression data samples into distinct classes is a challenging task. The dimensionality of the typical gene expression data set ranges from several thousands to over tens of thousands of genes. However, only small sample size are typically available for analysis. So to do this enormous amount of data analysis, we need to have high performance computing facility, which that Aneka platform is providing. Let us see that. This problem is often approached with learning classifiers, which generates a population of condition action rules that guide the classification process. Among these, extended classifier system, we call it as XCS, has been successfully utilized for classifying large data sets in the bioinformatics and computer science domains. However, the effectiveness of XCS when confronted with high-dimensional datasets such as microarray gene expression dataset has not been explored in this particular, because it is totally biological. But we wanted to show that this problem can be handled through the cloud. Okay, variation of this algorithm, COAX SCS, which has been published in by the eminent authors, has proven to be effective in these conditions. Next, this picture shows you the environment for microarray data processing on the cloud. Cloud OXCS task orchestra will be sending the data as a coaxial task, and that is shown in the pipeline here. These are the data sets. It will go and it will be sent to the Aneka platform. Aneka platform will work for this, and that will be analyzed by the Aneka platform. Okay, so CoXCS is a cloud-based implementation of CoXCS that leverages Aneka to solve the classification problem in parallel and compose their outcomes. The algorithm is controlled by strategies which define the way in which the outcomes are composed together and whether the process needs to be iterated. Okay. Next, we shall continue our discussion on geoscience, which I was mentioning that how geographical information system takes a large amount of data in terms of images, and these images need to be processed. Images will come as a stream of data, and this data need to be processed for the actual information. Like we know, Mangalyaan, Chandrayaan, all these problems we have seen that how they get the data from far places and then that is analyzed. Okay, geoscience applications collect, produce, and analyze massive amount of geospatial and non-spatial data. Okay, as the technology progresses and our planet becomes more instrumented, that is through the development of sensors and satellites for monitoring, the volume of data that needs to be processed increases significantly. In particular, geographical information system (GIS) is a major element of geoscience applications. GIS applications capture, store, manipulate, analyze, manage, and present all types of geographically referenced data. Okay. Geoscience satellite image processing. How do they do this? This type of information is now becoming increasingly relevant to a wide variety of application domains, from advanced farming to civil security and natural resource management. Please understand this. These are all very, very advanced topics you need to understand, because people are now thinking to make technology for agriculture, technology for rural development. So geoscience, geographical information system, is helping farmers also for doing advanced farming, looking at the soil condition, looking at the environment condition, looking at the weather condition. People are advised to do certain type of crops, and then they can get high profit. That is also being done through these geoscience projects. Okay, civil security as well as natural resources through this satellite only. Borders are being monitored, borders are being verified. You have seen these problems, in televisions and in cinemas. You can easily, you can understand this, how it is being done. Natural resource management also is being done. Along the borders, any activities going on, all these things. Anybody is trying to take our resources, they are using our resources, all that can be managed, and how effectively we can use our resources, natural resources also can be managed, in which area it is being. Because of this, nowadays, tsunami problems and flood problems, all these things are being highly alerted, because now using these techniques, it is very easy to handle situation, catastrophic failures. It can be easily done. Business continuity planning, disaster management, all these being handled through these satellite monitoring systems. As a result, a considerable amount of geo-referenced data is ingested into computer systems for further processing and analysis. Cloud computing is an attractive option for executing these demanding tasks and extracting meaningful information to support decision makers. Satellite remote sensing generates hundreds of gigabytes of raw images that need to be further processed to become the basis of several different GIS products. This process requires both I/O and compute intensive tasks. So cloud environment for satellite data processing, which has been given, it is a self-explanatory. Self-explanatory, you can easily see local storage is there. In the geostations, there is a station like MCF. There is a satellite which is monitoring, which is showing the information that is, SaaS, software as a service, is there to do the simulation, emulation of realistic picture, where you can take the image and then do the processing. Like, you can easily understand one important problem which all of us started using it. How do you get your IMAP as well as Google Map? How are you getting it? It's a geoscience project only. It is through the satellite. It is taking the images of the current location, and it is continuously monitoring, dynamically monitoring, so that it tells you all the traffic condition in a particular road, in a city like Bangalore, that. So it is also a problem related to GIS, Geographical Information System. Dynamically, it is being handled so good, so intensive. You don't feel the difference. There is no delay at all. While moving, it will automatically control it. How do they really tell you another 400 meters you need to move right? Maybe it is already available database, but dynamically also it is monitoring. It is telling you, don't go there, don't go in this path. There is a traffic, there is a control. You should take a normal path where there is no traffic and all. These are all dynamically handled. Even though there's a lot of databases available, it's a computing facility of Google helps you in accessing the data in a instantaneous way. Okay, so this satellite data processing is also being shown with respect to all service providers. Amazon, Microsoft, Google, all are providing this facility. Just for the sake of example, here it's a Zen server is another private cloud is supporting. Amazon Web Services, another cloud service provider, is providing the facility, and through this you are able to do satellite data processing and the geographical information system. I can easily do that. Okay, so the GIS normally requires both I/O and computing intensive tasks. Large size images need to be moved from ground stations, local storage, to the computing facility, where several transformations and corrections are applied. Cloud computing provides the appropriate infrastructure to support this data processing. Okay, a cloud-based implementation of such a workflow has been developed by the Department of Sales, Government of India, all governments, all foreign governments are also having projects like this, and they are having a facility like Amazon, Zen, Aneka, Google, Microsoft all are providing the facility. Okay. So next we shall move on. Next, we will move on to the business and consumer applications. So these are all scientific applications we have seen, biological applications we have seen, data intensive applications we have seen, and geoscience, so geographical information system, also uses cloud computing. That also we have seen. Next, we will see business and consumer applications. Very nice to see this, because we have taken so many examples related to this. Because if you look at Paytm, if you look at PhonePe, you look at Amazon store, Paytm store, okay, or any store which is available B2B, B2C, like e-commerce applications, e-commerce companies, whatever whoever is doing, they are all using the facility of cloud. The business and consumer sector is the one that probably benefits the most from cloud computing technologies. On one hand, the opportunity to transfer capital cost into operational cost makes clouds an attractive option for the enterprises that are IT centric. We can easily understand there is a two-wheeler facility which has been recently extended to all students also. Which is that? How do they handle it? It is also handled through the cloud. You can park anywhere you like. Just go and park it. Everything will be controlled through the internet. No need to lock it. All these facilities, just think over such problems related to cloud only. On one hand, the opportunity to transfer capital cost into operational cost makes cloud an attractive option for enterprises which are IT centric. On the other hand, the sense of ubiquity that the cloud offers for accessing data and services makes it interesting for end user as well. Ubiquitous computing is one important thing. IoT, Internet of Things, you require cloud. So whenever you think about IoT and cloud, cloud and IoT should be go together. Otherwise, it will not work at all. Moreover, the elastic nature of cloud technologies does not require huge upfront investments, thus allowing new ideas to be quickly translated into problems and products and services that can comfortably grow within the demand. So please understand this. So upfront investments or heavy investments are not required. If you want to start a company, you want to start a startup, one room, maybe 10 by 10 room is enough. Like Infosys started with that type of room. You can also do that, but you should properly understand the facility available in a cloud and how that cloud facility can be extended to your problem. But first of all, you should find a problem where it helps all and it is required by all, and for that you require a cloud. Then you can think of developing a problem like this and product for everyone to use. Okay, the first one, the problem is CRM and ERP. What is CRM? CRM is Customer Relationship Management. CRM and the Enterprise Resource Planning applications are market segments that are flourishing in the cloud. CRM applications. Earlier, CRM and ERP applications were there on the company, the enterprise, or totally it was being handled by them in-house. Expertise were required, in-house infrastructure was required to handle customer CRM and ERP enterprise resource planning applications. Nowadays, everything can be put on the cloud. Only those are sensitive information, those are secure, to be secure information can be kept in the enterprise itself, and all other things can be handled through the cloud. Cloud CRM applications constitute a great opportunity for small enterprises and startups to have fully functional CRM software without a large upfront cost and by paying subscriptions. Very easily you can subscribe. For example, you want to start a company, for 6 months you can pay a subscription and you can start. You need a computer, you need a laptop, and with a high-speed internet connectivity, you can start a company. Moreover, CRM is not an activity that requires specific needs and it can be easily moved to the cloud. Such a characteristic, together with the possibility of having access to your business and customer data from everywhere and from any device, has fostered the spread of cloud CRM applications. ERP solutions on the cloud are less mature, and to have complete with well-established in-house solutions, ERP systems integrate several aspects of an enterprise, finance and accounting. Actually, ERP is to be provided inside the company only, but if you are thinking that you can start your own company, then ERP also can be handled by the cloud. Finance and accounting, human resource management, manufacturing management, supply chain management, project management, and CRM also can be handled through this. Totally it is ERP, it is considered to be ERP. Financing, accounting is there, human resource management is there, manufacturing is there, supply chain management and project management are there in on the ERP solution. This can be adopted, this can be provided by any cloud service provider, and we can use them. Their goal is to provide a uniform view and access to all operations that need to be performed to sustain a complex organization. Okay, let me stop at this point. We'll stop again. We will continue. Please give me some time. You can go for question answer session another 15 minutes. Then we will come back for the next session.